Ever stop to think, like, the phone I have right here has more power than those huge GE computers that got us to the moon?
It really makes you think.
That's electronics engineering right there. It's shaping our world in ways we don't even realize.
Yeah, quietly driving everything.
So today, we're diving deep into electronics engineering, the past, present, the whole shebang.
It's a fascinating world. I mean, when you really get down to it, even the simplest gadget, it's incredible years of innovation, people working together,
Yeah.
over a century of breakthroughs.
It's true, like a hidden language everywhere around us.
It really is.
And speaking of hidden, our story starts with a tiny particle, 1897, the electron.
Oh, I see where you're going with this.
J.J. Thomson's discovery may not seem as flashy as, like, a Mars rover,
Right, right.
but it was the spark, ignited a revolution.
Absolutely. It's like we found the building blocks, a whole new universe, and it's electronic.
Exactly.
We weren't just watching electricity anymore. We were understanding it, you know? Just opened up so much potential.
And take off it did. Enter vacuum tubes. Talk about your OG tech.
The size of some of those things, unbelievable.
Huge. Imagine needing a computer the size of this room just to do some math.
Now we can do it on our watches.
I know. But those glowing tubes, they were essential. First computers, communication systems. But bulky, hot, inefficient.
Yeah, bit of drawback.
Looking back now at our sleek phones, it's wild those old computers were even a thing.
It's true.
But it was clear something had to change.
They had their limits.
And change it did.
Yeah.
1947, bam, the transistor.
Miniaturization.
That tiny speck of silicon replaced those massive vacuum tubes. It's like ditching your horse for a jet plane.
What a comparison.
But that's what it was, a total game changer. Suddenly, electronics could be small, radios you could carry, and eventually, our smartphones.
And that's where our friend Moore's law comes in.
Yeah.
1965, Gordon Moore. He noticed something. It's become a kind of golden rule.
Okay, break it down for us.
Basically, the number of transistors we can fit on a chip, it doubles every 2 years or so.
Doubles. Consistently.
More or less, yeah. That means things get smaller, more powerful, cheaper, all at the same time.
It's mind-blowing when you really think about it.
It is.
Without Moore's law, who knows where we'd be? We wouldn't have this constant tech evolution. Your phone right now is proof. More powerful than those room-sized dinosaurs from before.
And it's not just about smaller. It's about what that allows us to do.
Yeah.
We're talking things that were sci-fi back then. The things we can achieve keep growing.
It's like we opened a door, and there's this whole universe of possibilities, only limited by what we can imagine. But let's shift gears a bit, from the past to the here and now. If we were to step into electronics engineering today, what would we find?
You know, it's not just one thing anymore. It's like this huge web, all these different disciplines. Each one is unique, its own challenges.
So it's more than just circuits and, what's that law, Ohm's law?
Way more. You've got to get analog and digital signals, how to handle power, and don't even get me started on communication systems, the stuff that connects us globally.
Okay, now you've got me interested. Analog versus digital, what's the deal there? I hear those terms thrown around a lot, but...
Think of it like this. Analog signals, they're like a constant flow, like a vinyl record. The grooves translate the music into one smooth signal. Digital, though, it chops that up into tiny pieces, ones and zeros. That's how computers talk.
So digital, it's like you're taking that wave and going chop, 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 turning it into bits.
Exactly. And each bit has a specific value. And even though digital is everywhere, in computers, phones, everything, analog is still essential, especially for interacting with, well, reality.
How so?
Think about sensors, the kind that measure stuff like temperature or light. They usually start with analog signals and then convert to digital so we can use that data.
So it's all about the right tool for the job. Analog for the real world, digital for the computer world.
Exactly.
What about power electronics? Where do they fit in all this?
Power electronics, they're the unsung heroes. They make sure the right amount of juice gets where it needs to go. They're like the conductors of an orchestra.
Making sure the power is flowing smoothly.
Exactly. Your laptop, electric car, even the entire city's grid, that's power electronics working behind the scenes.
Wow, it's incredible how much we take it for granted.
Right. But we're just scratching the surface here. We haven't even gotten to communication systems, control systems, or even embedded systems.
And what about making sense of all those electrical signals? That's got to be a whole other thing.
Oh, absolutely.
It seems like we have a lot more to uncover in our deep dive into electronics engineering.
It's pretty amazing when you think about it, how these different parts of electronics engineering, all these different areas, they work together.
It's like a team sport, but with circuits and signals.
Exactly. Take communication systems, for instance.
Can't live without them these days. No internet, no smartphones, no thanks. We'd be back to like sending smoke signals.
Tell me about it. But think about it this way. All those signals, radio waves, the light going through fiber optic cables, they all use those same principles we talked about. Analog, digital, even power electronics. Got to make sure those signals are strong and clear.
Wow, never thought about it that way. So it's like this whole chain reaction, keeping us all connected.
Pretty much.
What about control systems then? Where did they fit into this whole electronic orchestra?
Control systems, they're the ones making sure everything plays together nicely. Think about cruise control in your car. Sensors keep track of your speed. Then the system adjusts the engine to keep you going steady.
Oh, I
And then
saw.
think about those big factories. Control systems manage all kinds of things there. Temperature, pressure, making sure the products are made right consistently.
So it's like having a conductor, but for machines, making sure they all hit their cues.
Exactly. And a lot of this is happening behind the scenes, right? Embedded in the things we use every day. Embedded systems.
Okay, I've heard that term, but what exactly are we talking about?
Those tiny little computers, microcontrollers, microprocessors, they're like the brains of so many devices.
So the silent partners, quietly making things work.
You got it. Your coffee maker, your washing machine, even your fitness tracker, they all have embedded systems. And as technology gets more advanced, those little guys are getting smarter and smarter.
That makes sense. So speaking of smart, let's talk about the future. Electronics engineering is moving fast. What are some of the big things on the horizon, the stuff that's going to blow our minds in a few years?
Well, we already touched on the Internet of Things, right? The IoT, connecting everything around us.
Yeah, I can barely keep up with the devices I have now.
Right, but imagine your fridge ordering groceries when you're running low, your thermostat knowing just how you like the temperature, your car driving itself.
It's a lot. What could possibly go wrong?
That's the thing, isn't it? Security, privacy, we have to think about that. It's not just about cool gadgets, it's about using them responsibly.
For sure. So what else is coming down the pipeline in electronics engineering? What other breakthroughs are shaking things up?
AI and machine learning,
Hmm.
artificial intelligence, that's a big one. It's already everywhere, from healthcare to finance, and it's only going to get bigger.
AI, so that's computers learning on their own, right?
Pretty much. Analyzing tons of information, figuring out patterns, making predictions.
Some a little creepy, a little cool, all at the same time.
I know, right? But think about the possibilities. Imagine personalized healthcare, wearable sensors that can tell you if you're getting sick before you even feel it.
Okay, that would be really helpful.
Exactly. But again, we have to be careful about data privacy. But AI is just one piece of the puzzle. We're also talking wearable tech, flexible electronics, heck, even quantum computing is on the horizon.
Quantum computing, that sounds like something out of Star Trek.
I know, right? It's still early days, but this stuff has the potential to be huge. Things that would take our best computers, years, centuries even, quantum computers might be able to do it in minutes.
Whoa, that is some next level stuff.
New drugs, new materials, who knows what we could discover. But it shows just how important it is to have smart, ethical engineers. We need to make sure this technology is used for good.
That's a great point. We can't lose sight of the bigger picture.
Absolutely. And while we're looking ahead, we can't forget about the basics either, like communication networks they need to keep up.
Faster internet, I'm all for that.
Right. 5G is rolling out now, but 6G is already on its way. Faster speeds, lower latency, it's going to change everything.
Holographic video calls, sign me up.
Exactly. But it all takes energy, right?
True. All these gadgets, they need juice.
And that's another big challenge. Energy efficiency is huge. Energy harvesting, that's a big one.
Energy harvesting, what's that?
Imagine capturing energy from the environment. Sunlight, heat, even vibrations.
Wait, so you're saying my phone could charge just by me walking?
Maybe someday. It's about making electronics more sustainable. And then there's material science. We need new materials, better than silicon.
So not just new ways to use electronics, but new stuff to build them with.
Exactly. Graphene, for example, it's just one atom thick, but it's super strong, flexible, and it conducts electricity like crazy. Or silicon carbide, it can handle way more heat than silicon. That's big for power electronics. We're talking faster, smaller, more powerful devices.
It's amazing how all this stuff connects, from the tiniest particle to the biggest ideas, but in the end, it's people who make it all happen. The engineers, the dreamers.
Couldn't have said it better myself. And that brings us to another important question. What does it take to be a part of this world?
Right. What do you need to succeed in electronics engineering? So we've journeyed through this amazing world of electronics engineering, right? From a tiny electron to quantum computers, it's mind-blowing. But now let's talk about you listening.
What if you're thinking, this is all cool, but could I ever actually do this stuff? Do I need to be like some kind of math whiz?
Well, loving tech never hurts, and being a little curious.
True, true. But seriously, you do need that solid base in math and science. But there's so much more to it. Electronics engineering, it's bigger than just equations.
Right, because even if you're a total genius, you gotta explain those ideas, work with a team, and tech changes so fast, you gotta keep up.
Exactly. Being able to communicate, that's huge. These days, especially in engineering, it's collaborative. You're not just stuck in a lab by yourself.
So you need those people skills just as much as the technical ones.
Absolutely. You got to explain complex stuff clearly, listen to others' ideas, work together. It's not just about being the smartest person in the room.
So it's like this balancing act, right? You need that technical expertise, but also that creativity, that problem solving. And don't forget being a people person.
Exactly. And being able to adapt. This field, it never sits still. New stuff is always popping up.
Like being an explorer, but the map keeps changing.
Right. You got to be okay with not knowing everything, ready to learn and shift gears when you need to.
But explorers have tools, maps, compasses. What do engineers have?
Oh, we've got our own toolkit. Knowledge, practical skills, and these days software's huge. We use it to design, test, the whole 9 yards.
And I bet a little stubbornness helps. Engineering's got to be tough sometimes, right?
For sure. You'll hit roadblocks, things won't go as planned. But that's part of it. Makes the victories that much sweeter.
Makes sense.
Plus, who wants a boring job? In this field, you're working on things that matter, solving real problems that affect people's lives.
It's like you're building the future. That's got to feel good.
It does. Whether it's new medical devices, green energy solutions, or, I don't know, the next super fast internet,
Yeah.
you can make a real impact.
And the possibilities just keep growing.
They really do. AI, robotics, you name it. If you use electronics, there's a place for you to make your mark.
So for those of you who are hooked, you're feeling that spark, where do you start? How do you jump into this whole world?
The first step is easy. Just don't be afraid to ask questions. Read everything you can get your hands on, play around with electronics kits, find some mentors, people already in the field. There's so much to learn, and the more you learn, the more you realize how much more there is to know.
It's like we've opened this door and it just keeps going.
It does. And you don't need all the answers right away. Enjoy figuring it out. The journey's part of the fun.
So there you have it. The world of electronics engineering is waiting. Who knows? Maybe you'll be the one to make the next big breakthrough. Thanks for joining us on this deep dive. We'll see you next time for another adventure in the world of tech and science.